Hello dear students, in this video I'm going to solve another question that is related to projectile motion. So this is question number 8. An aeroplane shown diagram below is traveling at the horizontal speed of 95 meters per second. So here is an aeroplane that is traveling, its speed is given, that is equal to 95 meters per second. It has to drop a crate of emergency supplies. The air resistance is acting on that may be negligible. Okay. The crate is released from the point P. Here the crate is released and lands at the point Q. Sketch the path followed by the crate between P and Q. So the path followed, we have to find the path followed. We have to we have to draw the path followed by the crate. Okay. So as we know that when any object move in the moves just like projectile moves in the under gravity, so the path followed will be the parabolic. Its path must be equal to parabolic path. Okay, so parabolic path is, so we draw this parabolic path here. Here is the path followed, that is the just like a parabolic path. Okay, now explain why the horizontal component of the velocity in a curve remains constant while it is moving in through the air. So we have to explain the horizontal, why the horizontal velocity component will be constant, remain constant. So as we know that when the crate is moving down, it has, and at any path it has two components. The velocity has two components. One is the x component, that is the x component, and other one is the y component, and other one is the y component. As we know that when the projectile is moving, is landing, so its horizontal is component is not going to change, but vertical component increases. But we have to explain in this question, we only discuss the why the horizontal component remains constant. So simple reason is that the horizontal component is constant due to, because there is no horizontal force acting on this, because only the force is force of gravity in the projectile. In the projectile we know that the only force that acts on this is the gravity, force of gravity. So gravitational force is responsible, okay, to move this gradient downward. Okay, so no horizontal force acting on this, only this gravity is a vertical force. Okay, gravity is, remember that gravity is the directed along the vertical direction. No horizontal force acting on this horizontal direction, so that's why its horizontal component will not change. Okay, we can also quote this horizontal component with this with the Newton first law. According to first law, if there is no external force acting on this system, so there is no change of speed. Okay, so in the horizontal direction is no force acting, so no change of speed. So let me write this. Okay, so as we know that no horizontal force acting along, no horizontal force acting along, no horizontal force acting, no horizontal force acting. Okay, and horizontal thus horizontal acceleration, horizontal acceleration remains constant. Okay, remains constant according to first law. according to According to first law of motion, Newton first law of motion, if no external force acts, the body moves with constant speed, with constant speed. Here the speed is constant, horizontal speed is constant, because there is no force along the horizontal direction. Only the force is gravity that acts on the vertical axis. So that's why no force on the horizontal axis, that's why horizontal component remains constant throughout the motion. Now for the part B, to avoid the damage of the crate, the maximum vertical component of the crate is vertical landing on the should be 32. Okay, so maximum vertical component is given, that is 32 meter per second. Vertical component is 32 of velocity. Before final component is Vy is equal to 32 meter per second. Okay, because V is the final speed. Okay, so show that the maximum height from the with the crate is drop is 52 meters. So we have to find the height is and this we have to prove that height must be equal to 52 meter. Okay, we use simple uh, uh, equation, that is equation of motion that is equal to 2a s equal to final velocity square minus initial velocity square. Because motion is vertical, we can say that this is vertical. As we know that initially when the crate is dropped, so initial vertical component is 0, uy is equal to 0, and finally when it lands, so vy is equal to, we have to find this speed. We know that this speed is given, that is 32, now to a is equal to g, as we know that acceleration is g, so we put acceleration 9.81, distance s is, we have to find the height, that is h equal to, instead of s we can write h. Okay, vy is vertical speed, that is equal to 32 meter per second inverse whole square minus 0 square. Okay, so for height h is equal to 32 square minus 0 square over 2 into 9.81. Okay, now we solve this and we get height, that is equal to 50.2 meter. So we can round off 52 to significant. So for the part C, calculate the time taken for the crate to reach the ground if the crate is dropped from the height of 52 meters. So we have to find the time. So given information is, time is unknown, height h is 52 meter. Okay, so we have to apply the equation again. Equation of motion, that is s is equal to ut plus half gt square. Acceleration is g, so that's why we can write g instead of a. Okay, now uy is again 0, and s is the height, that is given, s is equal to h is equal to 52 meters. So 52 meter equal to 0 into t plus sorry 9.8. So here we can write, instead of g we can write 9.8 divided by 2, 9.8 divided by 2 into t square. So we have to find the t. So we rearrange this to 0 will be cancelled, so 52 equal to half into 9.8 into t square. So we rearrange, so 2 is multiplying other side and divided by this 9.81, 9.81, 9.8 on and t square. So we solve this, t square is equal to t square is equal to 52 into 2 divided by 9.81. Okay, now if we further solve, finally if we take the square root on both sides and solve this bracket terms, 52 into 2 divided by 9.81. Okay, so finally t is equal to, if we solve this, get t, that is 3.3 seconds, 3.3 seconds. Okay, now for the third part, if r is the point on the ground directly below p, okay, calculate the horizontal distance covered by the qr. Okay, so I repeat this. For example, here is the p point, here is the q point, here is the r point. Okay, so just this is the below r. Okay, so this distance is qr, we have to find horizontal distance qr. So in order to find the horizontal distance, x is equal to qr is equal to what? Okay, so we use again equation of motion, as x is equal to velocity v into time, velocity v into time. So velocity is, we know that velocity is 95, that is equal to 95 into time is 3.26, 3.26. So we multiply this and we get 310 meter. Okay, so velocity x is equal to velocity into time, so velocity is 95 multiplied by 3.26. So for the part C, in practice the air resistance is not negligible. Stand explain effect of it this has on the maximum height from which the greatest drop. Okay, so if we assume there is a air resistance, okay, it's not zero, it's not negligible, then what is the maximum height? So simple is that maximum height greater, then if air resistance, if we include the air resistance, if there is air resistance, so maximum height is greater, maximum height is greater. Why? Because because vertical acceleration is less. So I explain this. Vertical acceleration is less, and it means in other words, the crate will larger to accelerate. Okay, I will explain it from the mathematics point of view and physically. Okay, both things I will explain. Okay, so first of all, I explain with the mathematics. Okay, so as we know that here is the point P, here is the point Q, here is the point R. Okay, now when the the trajectory of this crate is this, like this. Okay, so this is without air resistance, without air drag or air resistance. Okay, now this is the original path of the uh, trajectory of this crate. Okay, now for example, when air resistance include, I will use different marker, blue marker. Okay, for example, when air resistance include. Okay, so that as we know that air resistance is acting on the upwards. Now there is a force, that is the air resistance, that is the drag force. Okay, acting along opposite to the motion, it means that there is a opposite motion. It means the speed of this crate will decrease. It will go further away, so its point Q will shift, Q dash will be shifted. Okay, Q dash will be larger. You can see that this length, I dot the blue line, this length and this red length. So I see that the blue length, that is the after the drag force, the length after changing height, after introducing the G, is greater than height without G. You can see that this is physical. Okay, now I will explain mathematically. Okay, now if we use the third equation 2s is equal to v square minus u square. Okay, so s is equal to h is equal to v square minus u square over 2a. Definitely here is height is and acceleration. As acceleration reduces, because when air drag introduced, so speed decreases, mean the acceleration will decrease. Okay, so change of speed decreases, so it means the acceleration will decrease. So downward acceleration is decreasing, so it means the height must be the greater, because you can see that from the formula, height and the acceleration will be inversely proportional. So if acceleration is less, so I mean the height will be greater. So this is mathematics point of view, I explained this. Okay,